Anna McDonald is a universe-class expert in Kafka, and in particular Kafka streams. Kafka streams is an important part of the ecosystem, and I wanted her to give us an introduction to the topic, good solid foundation in Kafka streams, on today's episode of the Real-Time Analytics Podcast. Let's listen in. Hello and welcome to another episode of Streaming Audio. I am your host, Tim Berglund, and I'm joined here today by my friend, Anna McDonald. Anna is a customer success technical architect at Confluent. Got it. Better known as the Duchess of Siesta. Anna, welcome to the Real-Time Analytics Podcast.
Thank you very much. I can't believe I'm allowed on another one of your podcasts. I find that amazing, and I was invited. That's all I'm going to say. I didn't crash it.
Literally texted you and asked you if you wanted to. I usually say when I have a returning guest that it is on your part the triumph of hope over experience. But I'm glad to have you back. So,
yeah, thank you. I'm glad to be back. This is awesome.
It's a new podcast. Just I feel like back at the microphone in the studio again. Good to have you here. Okay, so Anna, if there's someone who somehow doesn't know you. What does a Duchess of Siesta do, and how'd you get there? A little quick background on you.
Sure. So I was a principal software engineer. This is what I'm doing currently is my second job of all time. Clearly quite a mover and shaker. Mm-hmm. And what I was doing was basically event streaming at my old job, and I fell in love with it, and I fell in love with Kafka. And I started to use Kafka streams. It was wonderful. And I loved using it for our use case, but I wanted to see them all. And so when I joined Confluent, I decided to go into the field. So as a Siesta, we do, technical, very, very deep technical things, from everything from brokers to transactions to event streaming, patterns. How do I do this? It's just really a real world connection to technology is the way that I would describe it. And it's never boring.
Yeah.
Right. I hardly ever say that, but I can honestly say, being a Siesta is never boring. So I love it.
Yeah, it's all kinds of different things, which I know for you is important. And other organizations, so you might know the role as TAM, technical account manager out there.
Yep.
Yeah, so your background, like you said, is principal software engineer, and you work with Confluence customers, helping them solve problems, do things, figure out new ways to use Confluence services, that kind of
Absolutely.
People build stuff.
That's right.
Yeah. So
successfully.
That is in the title. That's the problem with
failure is not an option.
It's not. A technical account manager, failure might be an option for them, but
correct, but not us.
Customer success technical architect.
We're architecting success.
You really are, technically.
Yeah, love it.
Technically, you're architecting success.
Right, technically.
So you, and that's one of the fun things about talking to you is that things aren't theoretical for you. You're actually helping people solve problems.
We're applied all day long.
100%. And one of the things that I know you've spent a lot of time focusing on and specializing on, and something you're passionate about, is Kafka streams, and that's what I want to talk to you about today. So
that's awesome. Yeah. And yes, I am. All of the above. I
think we're going to do a two-part Anna McDonald series here. For your beginning on the Real-Time Analytics Podcast. I think it's going to take two parts for us to really get through Kafka streams, but I'd like to start today. Honestly, I want you to pretend that I and our listening audience don't know what Kafka streams is. There's a lot of technologies in the broad analytics, streaming analytics, real-time analytics ecosystem. Tell us about Kafka streams.
So it probably begins to start with, this is what I always love, right? So when I was doing this and how I found Kafka streams was I fought to get all of our data into Kafka. And once it was in Kafka, I was like, yes. And then I was like, oh, but now how do I transform it? Oh no, what have I done? Right? And then and you would think that I would have researched the entire AK ecosystem and known that Kafka streams exist, but I'm kind of a JIT, just in time
sure.
person sometimes.
You know how to write a consumer and a producer, so.
That's right, with my evil plans. Successful plans. And so what I knew was that getting, especially a new platform into an enterprise or anything that's like strategic, like, those companies that it's not easy, right? There's a vetting process. And so I looked at, a Flink, which is, great for some things, a Spark, which is great for some things. And I then saw Kafka Streams, and it was a jar file. And I was like, was this created just for me? Like, who did this? Right. And I was like, this is wonderful, because as most companies, we already had, an entire platform for deploying microservices.
Mm-hmm.
I was like, this is, I can do eventing with a microservice approach. This is great.
You're already deploying microservices, and it's just a library.
Correct. And then out of the gate, I'm like, and wait, this is built specifically for Kafka. I can inherit all the goodness of failover, resiliency, sharding that Kafka already has.
Mm-hmm.
I was like, how could this be any better?
Right.
And so I found it. I fell in love with it. Also, it's a very fluent, the DSL is a very fluent style, kind of not object-oriented approach, which made me, actually like something about Java. I was like, oh my gosh, I can, if you've seen my Twitter rants, I think it probably makes more sense.
Actually, I've seen some Twitter rants about Java syntax recently. This episode is being recorded on April 14th, 2023. There's recently some discussion of two-dimensional array syntax in Java, and I didn't really see anybody come to Java's defense. So let's just give that one. I didn't know you were not a fan of object-oriented things. I mean,
I'm not whatsoever. Okay. My brain doesn't work that way. Okay. I have a very functional brain.
Yeah, and Kafka Streams is, if you've been looking at things in the last 10 or 15 years, libraries that deal with collections and all of those have, even in not purely functional languages,
correct,
have all developed very functional semantics.
Mm-hmm.
That's what Kafka Streams feels like. Yeah.
Yeah, exactly. And so, out of the gate, right, the other great thing about Kafka Streams is it comes out of the box with statefulness. So I always say in eventing, usually things tend to not get interesting. And by interesting, I equate that to valuable too, until you bring state. Mm-hmm. Right. Many times you're going to want to do enrichments. You're going to want to do references. You're going to want to keep a key value, and Kafka Streams provides that out of the box as well, sharded.
Compute and aggregation. That's
correct.
That's a rather stateful.
Yeah, I want to do a group by. I want to do a lookup. Right. I need to keep state in my application. Kafka Streams allows you to do it in memory or durably. Out of the box, right? It, bundles RocksDB, and also handles the sharding of said state. So it's all these kind of wonderful things strung together in a jar file as a microservice. So that's kind of at its core what it is.
Got it. So let me summarize for the uninitiated. It's a Java library. We said Java implicitly.
Mm-hmm.
We have complaining about certain syntactical affectations in Java. But I mean, Java is clearly extremely popular library or language for a lot of, we'll say business software. Okay, Java library. It's not separate infrastructure. You don't have like a Kafka Streams cluster. You've got your application, and you get
Mm-hmm.
stream processing functionality bolted onto it. I want to deep dive into state in a minute, but I want to back up. And you said fluent, and if anybody doesn't know what we mean by fluent, that means basically you kind of start with some object, and I want to ask about what those are in a minute, and then you do something to it. Like say you have a stream and you want to filter it. So you use stream.filter, and then that filter method, you can say dot do the next thing, dot do the next thing. So each of the methods returns the type or a type that you can keep doing this stuff to. So you end up with this dot, which is just super readable, right?
It's a pleasure to read.
Yeah. And some of these, like the functional things, some of these will be passing in lambdas and maybe get into that. But that's Fluent, and I'm 100% with you that it's the right way to do an API like this. What are the core abstractions inside Kafka Streams? Like, so what do I have to know? Suppose we know Kafka, like there's topics, there's messages. Now what? What are those objects that you start a Kafka Stream application with?
So there's two real core objects, right, in our DSL that we want to talk about, and those are a K table and a K stream, right? Kafka Streams, 101. A K stream is, as it might sound, stateless. It's a streaming representation of your data, right?
like
hence the stream.
a wrapper
Right?
around a topic. You can think of it
Correct.
just as a topic.
Exactly. So I'm going to create a K stream off a topic, right? I'm going to ingest data from a topic, consume it, and then stream it. And as you said, right, the nice thing is, right, so I've got this stream. What do I do with it? Well, maybe I want to filter it. Maybe I want to branch it, right? Maybe I want to take in that incoming state from a stream and I want to do a group by or a map or a reduce or and all these wonderful things. And then when we look at this, as soon as you get into, okay, well, but I need to do some joins or I want to do some windows or that's when kind of statefulness comes in, and that's a K table. A K table is Kafka Stream's representation of a key value store.
Gotcha. So that makes sense. Yeah, that K table is a stateful thing. It has some in-memory representation. The stream is really just kind of feels like a lightweight wrapper around a topic.
Right. Right. And when we say kind of like in memory too, like that's the other nice thing is that, when you think about this, you're like, okay, well, in memory, oof, right? What if it gets really big?
Yeah.
Right. So in rocks, you can also, you go durably to disk, and rocks will keep, right, those files, those log files, segment files on disk. All of that is backed durably to what we would call a changelog topic in Kafka. So if somebody comes in and blows away your state store that's sitting there on disk, it can be rebuilt from a changelog topic in Kafka. So it's durable.
Got it. So let me rebuild that scenario for a second. So I've got a K stream, that's a topic. And I do something that basically turns it into a table. Like maybe I'll do a filter or map, blah, 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 trend, but then I group by some field. Well, the output of that, just stop and think for a second. I've got these messages coming in and I'm going to group by postal code. Well, postal code is now the key in what's effectively a hash table, right? That's what you've done. You've grouped these messages by something. And so now all of a sudden, that's this K table thing you're talking about. That's a key value store.
Right. Yeah, and you can materialize that into a state store, right? And then usually, like you can name it, you can do different types of stores, but that's exactly right. Yeah. So it's about, well, how do I want to represent this data? What do I want it to look like? And obviously you have to kind of keep that somewhere as you come in and you're grouping by or as you're aggregating, right?
Right. Now, a question I've gotten in the past, which is, I think this is a junior programmer question, and all senior developers start as junior developers, so that's a respectable place to be. But why would I use this API? Why wouldn't I just write this stuff myself? And what Admiral Akbar, my friend Admiral Akbar, has to say about that.
Right. It's a trap.
It's a trap.
Right. And I tell you what, anytime I go into a customer and they go, well, we're using sticky partitioning and static partitioning. And I look at them and I go, and is that because you need the same instance to pick on the same partition every time because you're trying to manage state, like sharding state yourself? And they're like, well, yes. And I'm like, yeah, no, Kafka Streams does that for you.
Exactly. So you started with like filtering or splitting or something. So those sound stateless. And so you could imagine just writing a consumer consumes a message. Well, does it have this or this? Okay, produce. Yeah, fine. I could write that. But once I do that group by, and again, I can make a hash map. I can type the Java code, but that doesn't scale. That has to be on heap, and it's not persistent. And so all of a sudden, there's a massive amount of functionality you realize in this thing. You said RocksDB.
And how do you transfer it? Like, what if it dies? What if that instance dies? Do you have a standby?
Oh, no. Yeah. Oh, I remember one person who was not a particularly junior person said, well, why wouldn't just put that in an in-memory data grid? I'm like, well, that is what you would say if you happen to have an in-memory data grid lying around. You don't want that. So yeah, you've got this RocksDB. If you don't know what RocksDB is, put a link in the show notes. It's interesting. It's a open source key value store, or the log structured merge tree internal. It's cool, right? And that's by default, that's how Kafka Stream stores that stuff. And you said that key value store, I forget what you called it, but it gets persisted to basically that stuff is replicated inside Kafka too.
Yes, absolutely. So absolutely. You inherit all the durability.
Yeah. Nice. Okay. And we started, let's get back to state. So yeah, I said I wanted to back up and talk about K streams. and I know it's just kind of summarizing that, but state's a big deal. And you mentioned sharding and failover and things like that. So once you're doing something stateful in a stream processor, if you're writing that code yourself, again, Admiral Akbar tried to warn you. Talk about how that works in Kafka. I'm interested in that.
So, right, the thing in Kafka Streams is there are two main types of tasks. There's an active task, and then we have something else called a standby task. The job of those tasks when we have state, right, is to look at that and go, okay, when I'm doing change logs or I'm reading from this topic, I'm responsible for the connection between state, right, or processing or whatever it is, and this entire, what we call a topology. And that's probably important to digress a minute. So in Kafka Streams, yes, we have a source, we have a processor, and we have a sink. Those things together make up a flow. So in Kafka Streams, we have, we call that a topology. Overall is your big one, and that's made up of many sub-topologies. And those sub-topologies involve a source, processing, and a sink. And so when you look at these, the way that Kafka Streams works is it says, hey, because in Kafka, right, the only order guarantee is by partition, we can safely assume that processing along these partitions is safe. So if I'm doing everything on partition 0 as I go, and everything is co-partitioned, right, and the keys are the same, and you can, fix, if they're not, you can kind of repartition in Kafka Streams and fix it.
So I've got two topics that a topology is acceptable sources.
Right.
Yeah.
You can come in, you can, rekey them so they have the same key and the same number of partitions and go. All of that is safe. What that means is, and the reason why we're so careful to do that is, I can safely take that task, working on those code, and pop it to another instance. I can assign it to another instance if this one goes down. So these are, these are kind of self-sustaining, isolated little streams of data that are able to be migrated in the case of a failure. And that's how sharding works too. So when we look at this and we look at the way that the shards work, they're all safe because at any time they're this encapsulated thing, self-sustaining, that kind of was like, hey, I can pick this up and put it here, pick it up and put it there, pick it up and put it anywhere, right? When we talk about that migration. And that's kind of just to tie a little bow around it is why we have active tasks and standby tasks. Because for those large stateful applications, as you might imagine, let's say that your application dies and Kafka Streams is not 100% sure if what's sitting on disk, let's say your data is so big, you've got that local state on disk. And Kafka Streams is not sure if that local state is good or not. So safety first, it will replay the change log. Now, that could be a lot of data, right? And so that standby task is sitting over there in another instance, quietly, reading in the same data that the active one was, building up state. And so if I die, Kafka Streams will go, oh, hey, standby task, you're active now. And that minimizes your downtime. It's beautiful. It automatically reassigns that. The state's already been building up.
You've consumed up to an offset that is... Okay.
Exactly. It'll catch it up and then goes, whoop, flips it on. And that has been a really kind of just a wonderful safety feature that's built in for a lot of these things that are mission critical, which is why, Kafka Streams to me, as somebody who does event streaming, more so than data pipelines, both which have analytics, right, in it, which is why we're still talking. I mean, we're friends too, but I mean about work.
We would be talking anyway, but why
we'd be talking anyway, right? Those are critical. Missed downtime can mean in an instance of, let's say, quality control, right?
Yeah.
You don't want your quality control for a given production line and a given type of thing to be offline for any amount of time.
And for I have to reconsume a substantial portion of a topic and build up that state before I can start consuming again. That's going to cause, potentially destructive latency. I'm thinking here as we're talking, we're saying a lot of Kafka stuff, and I will link in the show notes to some introductory materials if the stuff about offsets and consuming, and I was about to ask a question about consumer groups, and I'll link in the show notes if you're new to Kafka. Kafka's really a key thing that you have to have some familiarity with in this real-time analytics world. So let us just use the Kafka terms. We'll send you some links to stuff if you need the explanation. So on that point, just reassure everyone, go check there. standby task and active task, are those ideally on different servers? Is there any sort of awareness of that kind of thing in the way this is balanced?
Yes. So we just have rack awareness now in Kafka Streams. I say just, but it
Nice.
was in a little bit more recently, right? And so
Yeah.
there's a lot of features and functionality that you can do there too. Absolutely.
Nice.
To make sure that we're trying to be smart in the way that we assign
Active and
those standby tasks.
Yeah.
Yep.
But
Yep.
to Kafka, do those look like different instances of the same consumer group? Or
Right. Yes, because like if you think about it, right? Yeah.
Yeah.
Yeah. Well, so it's almost like, fetch from follower. The way that fetch from follower works, where you can, kind of pin a consumer to whatever rack it is for local. So it's kind of like that. So yeah, it's all about, and this is what I love is Kafka Streams in most 99.9% of the time, it's awesome, right? We inherit all the goodness from consumer group coordinators and consumer groups. Mm-hmm. And so just as you can do things to make sure that if available, right, a consumer can consume from the closest rack, you can do the same type of thing in Kafka Streams with a little bit of extra goodness, which is also to say, hey, and also, right, make sure I've got a good representation across the way for rack awareness for my standbys.
Got it. In a way that is similar to fetch from follower. Doesn't directly rely on it. Right? So now, okay.
No. Yeah.
Fetch from follower. That's another thing. We'll try and throw a link to that. I think that was like a mid to late 2021 Kafka feature, if I recall correctly. And it's actually interesting, and you have to know a little bit about how replication works, but it was like a nice extra thing that might make some consumes go faster or lower latency. Yeah. Mm-hmm. Okay. And that's the thing about Kafka Streams is it really is built. It's made out of Kafka, and so
correct.
At a top level, imagine if you just wanted to teach a Java programmer how to Kafka Streams without them knowing really anything about Kafka. You could get a start. You could say, okay, here's this abstraction that's a stream. It has things that happen, and they've got a key and a value, and you get them, and there's this functional Fluent API, right? And here's a thing called a K table, and here's how they work. And
and I would say that Kafka Streams does a pretty, it does now again, right? Like the ideal world, like there's nowhere in Kafka, and I think this is something, there's, for example, my friend Igor is doing, has started talking about this, and I think a lot of people are talking about like topics as a service, because no matter where you are in Kafka today, people still think about partitions, right?
Yeah.
And that is kind of a blocker. But in Kafka Streams, for example, if all you know is you have a topic and you have the name of a topic, right? And you want to consume from that topic and then maybe do a group by, you don't need to know anything else, right? You can do that, and then you can output it, to another topic if you want, right? Or, whatever else you may want to do.
Key point you just made there, the output, and you said this before, really, but I want to make sure everybody got it. A topology is a source, a processor, and a sink. That sink is a topic, right? So you read messages, you do computation on them, and you put them back in a topic.
Correct. That is the ideal form for Kafka Streams, right? We try to avoid side effects. Now, that's not to say that people do not do it all the time and say, I'm going to call a REST API in the middle of this.
A synchronous service in the middle of my asynchronous stream processing API.
Right. And not to also say that I haven't seen it work well, because I have, but because of the edge cases, right? And I, this is something actually that we've been talking about is that valuable functionality that we really want to clean up and all those rough edges and side cases and provide something like that out of the box. It's something actually we're kind of actively talking about now. But if you want to be, super safe, right? And also, I'll be honest with you, putting stuff back in Kafka to me, that's distribution because anybody can read it. Mm-hmm. So if Kafka is your central nervous system, you shouldn't be like, oh no, I got to put it back in Kafka. You should be like, Kool-Aid man style. Oh yeah. I'm putting it back in Kafka, like break through the wall and everything. And I'll be like, awesome sauce. So that really is a very valuable pattern, right? We just want to see, what's the demand? What use cases does this open? How is it going to help people? If we can kind of look at also saying, you know what? It's okay to do that. It's okay for you to do that.
Yeah.
and make it a little bit more safe.
I want to drill down some more into that. I want to talk about how you get at the things in a K table, and I want to talk about time and how we deal with time in stream processing. Those are good things to drill down into. That's going to be part 2. So
I love this.
My guest today has been Anna McDonald. Anna, thanks for being a part today of the Real Time Analytics Podcast.
This is like a teaser for next episode.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.